Hello guys, welcome to the first video of insightful lectures. Um, so this is my channel. Here I'll be posting lots of lectures based on physics, business topics, maths, and obviously chem and bio as well. So all the STEM topics. So the first topic is something that many people can confuse in some sort of way because given that forces there's a wide variety of topics within forces like frictional forces, types, causes, effects. So let's dive into that, but first we're going to tackle balanced and unbalanced forces and free body diagrams. So let's begin. So first of all, let's introduce ourselves to forces. So forces, you must have studied in your textbooks that it is a push or pull upon an object. Very monotonous, very boring, and yeah, you might assume that something and a person pushing or pulling it, an object. So that's very like general, and it doesn't. Okay, so provided there's a scenario, there's a rock and this is the ground. Now can you tell me, this is stationary, so is there any forces acting on this? Well, you'll probably say no, because but the truth is that there is a gravitational force acting to pull the rock towards the center of the earth, and a normal contact force to keep it stationary. So that means you haven't understood the concept of forces yet. So these free body diagrams, so forces are a vector quantity because it has magnitude and direction. So you can't just say, okay, I gave my object 50 Newton force. What? Where? Which direction? Left or right? Up or down? East or west? Like that. So that's why it's a vector. So the thing with vectors, yeah, you can't just add them up. You need to deal with the direction. So that's what we're gonna see here. So this is a free body diagram. This is, say, there's a 5 Newton force. So Newton is basically the SI unit of forces, and this is the unit in which forces are measured. 5 Newton force here, and 3 Newton here. Next scenario. This is a rock, and this time we have a character trying to push it. Character, okay. Uh, my drawing's so bad. This one note, yeah, drawing with a trackpad is very hard. But yeah, he's pushing the rock. Okay, he's pushing the rock, and this rock has. Okay, we're gonna give a free body diagram with a horizontal and vertical component. Horizontal component. And before we proceed with free body diagrams, it is important to know, when you want to be precise with it, the arrows, the magnitude of the arrows are represented by the size. The size of the arrows is directly related to the size of the force, and the direction where, if it's pointing here, the force is acting towards the right, and if it's pointing here, force is acting towards the left. So this is what it is in free body diagrams. So yeah, and yeah, this is it. Let's add some numbers. So this is the gravitational force, 3 Newton, let's say, and this is the normal force, equal and opposite force acting opposite to the gravitational force in the upwards direction, 3 Newton. So there you see the horizontal component. Let's calculate the resultant force for that. So these are in opposite directions. So when forces are in opposite directions, they subtract each other. So the horizontal component and the, so this is how you represent this. F, oh my god, this is taking a lot. Okay. Sigma sine F You can also show it like this. So these are two ways to show resultant force. Equal to, for horizontal component, this it is 0 Newton. This means that the forces are balancing each other out. These are balanced forces. Okay, one concept down. Now, this one, these forces, so this is the character is trying to apply a force to the right of 6 newtons. Very unrealistic, but okay, 6 newtons to the right and 4 newtons opposing him. So since the rock is in contact with the surface, it's obviously frictional force. So yeah, 6 newtons to the right. So F resultant force, or basically the combined force for the horizontal component, is 2 newtons. Oh yeah, horizontal components here, and 2 newtons to the right. So give the direction. So that is unbalanced forces. So whenever there's an unbalanced force, the object will move. Or whenever there's an unbalanced force, the object um, um, will move, or it will basically increase the velocity. So yeah. So and also an unbalanced force can set an object in motion. For example, let's give an example for that. Uh, OneNote. Talk about OneNote, eh? Okay. So let's give an example. This is a ball. It's moving. It's stationary, and this ball will now. I give it an unbalanced force of 4 Newton to the right. So now it overcomes the frictional force and starts moving. And then after some time, this ball will stop because of the frictional force. So yeah, so an unbalanced force can set the object in motion. So this is free body diagrams in a nutshell. So that's balanced and unbalanced forces, and I've given you a little intro into forces, and yeah, the notations and all of this. So this is very rough. If you want to be accurate, that I told you, the size of the arrows is the magnitude of force, and the direction in which it is pointing is the direction of the force, direction of movement. So yeah, that's what you need to remember: balanced and unbalanced forces. I'll meet you in another video. Thank you for watching.